Around 480 million years ago, the Earth was a very different place. The continents as we know them looked drastically different. England, Wales and Southern Ireland laid close to the South Pole, part of what we now refer to as Abalonia, whereas Scotland and Northern Ireland laid closer to the equator, part of what we refer to as Laurentia. When the land masses of this old Earth started to shift together due to the narrowing of the Iapetus Ocean, they formed Pangaea, the supercontinent. Scotland and Northern Ireland were joined with England, Wales and Southern Ireland, and the UK was formed. This means that the geological profile of the UK changes depending on where you are looking. Focusing in on northern England, and more specifically on Cumbria, we find a geological profile containing volcanic rocks surrounded by sedimentary rocks such as limestone. This creates an interesting landscape shaped over time by many processes. One monumental process in shaping the world's landscape has been the glacier. There have been 5 or 6 major glacial periods in Earth's history, with the most recent ending roughly 12,000 years ago. Just as the Earth was warming up again and this most recent ice age was nearing its end, something unexpected happened. The Earth started to become colder again. We call this period the Younger Dryas, named after the Dryas octopetala, a cold-loving flower. This relapse into freezing conditions forced the glaciers that were previously retreating to again advance through the landscape, shaping it one last time before their final retreat. Scientists and geographers alike believe this period lasted for around 1,300 years, making it a rough period to live through. We can see evidence of this brief glaciation through the landscape via fossil evidence of pollen and shifting vegetation patterns. Some theories suggest that this period of cold was induced by a cosmic impact from a meteorite or comet. A glacier is made up of vast amounts of ice, making it a force to be reckoned with. This might means that not much stands in the way of its path of destruction. Softer rocks such as limestone stand no match and will be swept away from their beds and forced down valley by the glacier. Harder rocks such as granite may also be picked up by the glacier's force, being moved and reshaped by them. This is why we sometimes find large boulders formed in ways that do not match up to the area's geological profile. Glaciers are formed in periods of freezing temperatures, meaning there is lots of snowfall. As this snow builds up, the snow at the bottom becomes compressed by the weight of the newer snow above it, pushing out the air and forming ice. This mass of ice will eventually become so heavy that it will start to slide downhill. Ice may also melt at the bottom of the glacier due to the immense pressure above it, allowing the ice sheet to move more easily. This is when the glacier starts to reshape the landscape. There are features of glaciation that we can look out for in the landscape that help give us more information on the movement of the glacier. Obvious features such as U-shaped valleys or flat plains show where the landscape has been shaped, but there are more subtle features that require an observant eye to spot that can give us more detail about the glacier's movement. Moraines, for example, are formed when the large amounts of sediment being pushed by the head of the glacier are laid to rest once the glacier starts to melt or retreat. This large pile of debris marks the furthest point the glacier reaches before retreating. This type of moraine is known as a terminal moraine, but there are other types. For example, a lateral moraine can be found on the slopes of valleys, indicating the edge of the ice sheet. Drumlins are formed when the ice sheet meets an obstacle that it is not capable of shifting. The sediment that the ice sheet was carrying is then deposited on top of this obstacle and is subsequently pushed over. As the glacier continues to move past this obstacle, the sediment becomes trapped behind it, creating a hill shaped like a half-buried egg or an upside-down Nike tick. As the glacier moves down a valley, it might erode the rock at the foot of the hillsides. This leads to a lack of foundation for higher parts of the hillside, leading to landslides and rockfall. Some of this rock may be caught by the glacier and carried down the valley and deposited when the glacier starts to melt. These out-of-place rocks are known as erratics. The rock higher up the hillsides that have been eroded that don't initially fall may then later fall, leading to a slumping effect at the hillside's feet. This might look like rolling mounds falling down the hillside. A tarn is a lake situated on a mountain or high up on a hill and indicates previous glacial activity. A tarn is formed when snow falls in a high up hollow until a glacier is formed. This type of glacier is known as a cirque glacier. The cirque glacier then starts to erode the surrounding rock, deepening the hollow until an armchair-shaped divot is formed. This is known as a corrie. When the glacier eventually melts, the water remains in this divot, creating a tarn. An esker is a long winding ridge formed of sediments transitioning from coarser sediments such as boulders and gravel to finer sediments such as sand as it moves downhill. Eskers are formed when tunnels are created under the glacier due to meltwater erosion, and the newly acquired sediment is carried through them by the water. The sediment is then progressively deposited on the edges of these channels, with the larger coarser materials being deposited first. As the glacier retreats, the tunnels disappear, but the eskers are left behind. Today, these features might seem like bumps and mild abnormalities in the landscape, but they can give us detail on recent glacial activity. For example, if a valley has many terminal moraines, we can assume that the one furthest from the valley head was the first to be deposited. A younger glacier would have shifted this moraine further down the hill if it reached that far, meaning that the moraines indicate the order of age, with the ones nearest to the valley head being the youngest and the ones furthest away being the eldest. Drumlins will slope in the same direction that the glacier travelled in, giving an easy way to imagine the past. Hillsides are eroded, mountains are shrunk, valleys are formed, and bumpy landscapes are flattened, meaning that much of the landscape we know, especially in the UK and chiefly in Cumbria, has been moulded by these glacial periods. Glaciers shape the landscape on a larger scale, but there is evidence to be found on the smaller scale too. As mentioned previously, fallen rocks can be carried by the glacier to new destinations. This can happen below the glacier as well, but under much harsher conditions. When rocks are carried under a glacier, the pressure applied can cause many to break and eventually erode into fine sediment. Those that can withstand the pressure, however, are subject to their own torment. As the glacier moves, the rock is scraped along the ground and by the base of the glacier, slowly smoothing it. Tougher rocks, such as granite, will be slowly transformed into more spherical, rounded rocks and will be deposited when the glacier starts to retreat. Using this information, we can look at a landscape and identify features that have been formed by glaciers and start to piece the story together.